Hi, Rockstars. Today we'll be advancing in our chemistry ignition series. In the last class, we talked about separation techniques. In today's class, we'll be starting a new series on atomic structure. We will be expanding this topic into three different parts. In the first part, we will deal with the introductory aspect of atom and its theories. In the second part, we will be talking about isotopy, isotopes, relative atomic mass, and relative molecular mass, percentage composition, and its likes. And in the third part, we will be talking about quantum numbers. In this class today, we will split the lesson into four different sections. In the first section, we will be treating the concept of atom, under which we will be expounding on Dalton atomic theory, its errors and modifications. Secondly, we will be treating the composition of an atom, the subatomic particle and their discoveries. Thirdly, we will be talking about the nuclear particles, under which we will talk about the atomic number and mass number. And lastly, we will be using this knowledge to crush UTME questions. Stay with me. Greetings, future rockstars, and welcome to Josh White Academy, where we fuel your success with experience-backed strategies and science-based tutorials. If you are new to this channel, I am your host, Josh White, and it's my mission to help you crush high school with confidence and clarity. So please do well to smash that subscribe button, turn on the notification. Let's get started. Atom was first explained by a Greek philosopher known as Democritus as early as 400 BC as the smallest part of a substance. Just like, imagine atom like picking an iron rod and crushing it to the point where you can no longer crush it. That smallest form of that ion is known as atom. Now, atom is the smallest or tiniest particle of a substance that can take part in a chemical reaction. So, some elements are found bearing just one atom. So we call them monoatomic. For instance, sodium, written as Na, just one atom. Mercury, written as Hg, have just one atom. Helium, written as He, have only one atom. They are monoatomic. So some can be diatomic. Most non-metals are. For instance, our hydrogen, the atomic means has two atoms in one molecule. Two atoms. We also have chlorine. You write it as Cl2. It has two atoms. You see it? We have oxygen. We write it as O2, two atoms. We have what we call triatomic, meaning they possess three atoms. For example, there is one main example, ozone, which is an allotrope of oxygen, is written as O3. is triatomic. We have tetraatomic, meaning it has 4 atoms in each mole of that element. Example is our phosphorus. It's written as P4. Then lastly, we have polyatomic, meaning it's more than 4. The main example under this is sulfur. Sulfur is written as S8. That means it has 8 atoms in one molecule of that element. So that's an atom. Now let's talk about Dalton's atomic theory. John Dalton made certain postulations, and at that time were held in high esteem, but recent development and researches by more current scientists prove them to have certain errors and were later modified. Like for instance, number 1, Dalton defined atom as the smallest indivisible particle. He defined atom as indivisible. That means atom has reached the lowest form that it can no longer be divided again. But discovery of subatomic particles by other scientists prove this theorem to have an error. So the modification of this theorem by Dalton is atoms are the smallest particles of an element or of a substance that can take part in a chemical reaction, no more indivisible. Secondly, he stated that atoms of the same element are exactly alike. The exactness of atoms. He said that atoms of the same element are exactly alike in every aspect and differ from atoms of other elements. Now, the discovery of this term known as isotopes nullifies this postulation, because isotopy rather is a phenomenon where atoms of the same element have the same atomic number but different mass number. For instance, chlorine, Cl, there is chlorine 35 and there is chlorine 37, and they all have atomic number of 17. So they have the same atomic number, but their masses differ because of their number of neutrons differs. So according to this, that says atoms of the same element are exactly alike in all aspects, this cancels it, because of these 2 atoms are the same, but they are not exactly alike because their mass numbers differ. And also the discovery of isobars, where more than one element can have the same mass number but different atomic number. For instance, potassium is 39 and 19. There are isotopes of calcium, which is 20, that can have a mass number of 39. There are also isotopes of argon, which is 18, that can have a mass number of 39. So you see, these are different atoms, but they have something in common. But Dalton stated that atoms of the same element are exactly alike, nullified, and differ from atoms of different elements, also nullified. Thirdly, he stated that atom can neither be created nor destroyed. This still holds true in ordinary chemical reactions, as explained by conservation of mass, that the before and the after still remains the same, that the reactant and the product still remain the same in mass. But the discovery of radioactivity, where an element like uranium can be split to form smaller elements, so it can be destroyed and new elements can be created through nuclear fission or even nuclear fusion. So this only holds true for ordinary chemical reactions. Lastly, Dalton stated that in a chemical reaction, atoms combine in simple whole number. So this also holds true for most inorganic compounds. For instance, calcium with carbon with oxygen. Calcium 1 atom, carbon 1 atom, oxygen 3 atoms. So forming a compound called calcium carbonate, limestone or chalk. So, but for even some inorganic compounds like triazosilicate, it does not hold true. And for most or many organic compounds, the atoms are in their thousands to millions, so they are not in simple whole number ratio, like carbohydrates, fat and oil, proteins. So in organic compounds, this postulation does not hold true. You know that knowledge is progressive. He made tremendous inputs to chemistry. But you know, what holds true yesterday can become erroneous today because knowledge is progressive. So a kudos to John Dalton. So let's move on to talk about the composition of an atom. As we said previously, atoms are composed of subatomic particles. So let's begin with electron. Electrons are negatively charged, found revolving on the shell or orbit. Now, electron was discovered by J.J. Thomson in the late 19th century. J.J. Thomson carried out a cathode ray tube experiment, and you know that gases on a norm do not conduct electricity, but when they are at low pressure and high potential difference (PD), they can be able to conduct electricity. He increased the potential difference to around 5,000 volts and reduced the pressure to around 0.0001 amp atmosphere. And he noticed a green light, and he called that ray cathode ray. And further experiments proved that cathode ray moves in a straight line and casts the shadow of any obstacle on its path. Number 2, it proves that also cathode ray is negatively charged as it is moving towards the positive terminal. Remember, in the law of electricity, electrostatic, unlike charges attract, while like charges repel. And thirdly, he noticed that this ray can cause mechanical motion. Yes. And later, this cathode ray was then called electron. So that was the way electron was discovered. And he noticed that atom is electrically neutral. That means if atom is neutral, that means there must be an equal positive charge that is neutralizing the already existing negative charged particles. So he engaged the same practical, the same experiment, but this time he used a discharge tube which has a central cathode and there was hole in it. He noticed there was a red ray moving in opposite direction to the green ray. And he, after many experiments, discovered that that particle is positively charged. And that one requires more electric or magnetic field to cause it to deflect, because a proton has more mass, about 1,840 times heavier than an electron. So it requires more electric or magnetic field to cause its deflection. So he discovered, and it was finally known as what? Proton. So J.J. Thomson discovered both electron and proton. J.J. Thomson proposed the theory of the structure of an atom, which was known as the plum pudding, the pudding model of an atom, where he said the atom is made up of negatively charged electrons that are embedded and positively charged protons that are floating in the atom. You know, at that time the knowledge he had was the only subatomic particle of an element were just proton and electron. But this could not stand future experiments. So this pudding model of an atom was debunked. Let's advance. Then, thirdly, so our second subatomic particle is proton, and thirdly, neutron. James Chadwick have that Nobel award for the discovery of the neutron. He did this by bombarding 18 sheets of beryllium with alpha particles, and he noticed the third subatomic particle found in the nucleus of the atom, known as neutron. Lastly, Rutherford planetary model of an atom. Two scientists alongside with Rutherford, Jaeger and Maxim, they bombarded an atom with alpha particles, and they noticed that most of the alpha particle passed undeflected. Some were deflected and some returned back in the same line. That proved that an atom had a large empty space with a small centrally placed dense nucleus, which was causing the deflection. So he used alpha particles to bombard that, and he noticed that some particles were deflected and some were reflected back, meaning that atom has a large empty space with a centrally placed dense nucleus which is positively charged. And this became the basis of the nuclear model of an atom. Rutherford also explained that the proton, the nucleus, is positively charged because of the presence of proton and neutron, and that the electrons are found revolving on the orbit or shell, like the way the planets revolve around the sun. So he postulated the planetary model of an atom, like the way planets revolve around the sun and the sun being the nucleus. So that was the most accurate at that time, but there were modifications to the postulation of Rutherford, like Niels Bohr, who stated that when electrons revolve around the nucleus, they do so at a particular energy level. So that's it. The composition of an atom. Atom is made up of electron, which is negatively charged, proton, which is positively charged, which also has 1 unit, but is 1,840 times denser or heavier than the electron. And lastly, the neutron, which does not have any charge. Proton and neutron are both found in the nucleus. The proton and neutron are both found in the nucleus, whereas this is the shell. The electrons are found revolving round the nucleus in the orbit, which is at a particular energy level. Now let's advance to talk about the nuclear particle. Now we'll be talking on atomic number and mass number. The atomic number and the mass number. Now remember, when we drew an atom, it has a centrally placed dense nucleus with the electron revolving around on the shell, and the nucleus contains the proton and neutron. Now, atomic number has the symbol of Z, whereas mass number has the symbol of A. Atomic number is also known as proton number because it is simply the number of protons found in the nucleus of an atom. Yes, it can also be the number of electrons in an unreacted atom. That means proton and electron are the same. That means in a neutral atom. That means electron has not been lost or gained. So the atomic number is the number of protons in the nucleus of an atom, or the number of electrons in a neutral atom. Now mass number. Remember we said the mass of an atom is found in this centrally placed nucleus. So the mass number is the number of the nucleus, or better said, nucleon number. So mass number is also known as the nucleon number, or the atomic mass. So it is the sum of the proton and neutron in the nucleus of an atom. So mass number is equals to, so mass number is equals to proton plus neutron, whereas atomic number is equals to proton or electron in a neutral atom. So these are the important things you need to take note. Atomic number, the normal numbering of elements. If you want to understand this more, check the other video that I made on the chemistry basics, the first 20 elements. So atomic number is the normal numbering of elements in the periodic table, and it's equal to the proton number or electron number in a neutral atom, whereas mass number is proton plus neutron. Now, let's use this knowledge to go and crush UTME questions. Come with me. Now the first question. The nucleus of an atom contains, remember during the class we said in an atom, the electron revolves around the shell or orbit, whereas the nucleus contains the proton and the neutron. So that makes our answer to be what? E. To the next question. The discovery that protons and neutrons are concentrated at the nucleus of an atom was postulated by Ernest Rutherford, John Dalton, J.J. Thomson, and Niels Bohr. Remember we said in Rutherford's experiment, nuclear theory of an atom, where he used a gold foil and he bombarded that gold foil with alpha particle, and he noticed that most of the rays passed undeflected, showing that an atom has a large empty space, but some of the rays were deflected and some even went back, meaning that there is a tiny concentrated nucleus, where he explained that this nucleus was actually comprised of proton and neutron. So the discovery that proton and neutron are concentrated at the nucleus of an atom was postulated by E. Rutherford. That's Ernest Rutherford. And he also went further to postulate the planetary model of an atom. The answer is Ernest Rutherford. To the next question. How many protons, neutrons, and electrons respectively are present in the atom cobalt? It has 27 atomic number and 60 mass number. Always note that the mass number is above, whereas the atomic number is below. Now, please take note of that word respectively. It means accordingly. So we will find the proton, the neutron, and then the electron. Now, remember we defined our atomic number as the number of protons. That means our proton is what? 27. And also, our electron too is also 27. Because this is a neutral atom, it has not reacted. So, that means it's 27 at the beginning, 27 at the ending. Or it's proton and electron. Then neutron. Remember we said the mass number is the number of the nucleon. That means proton plus neutron will give you your mass number, where the mass of an atom is concentrated. So our mass number A is equal to proton plus neutron. Our mass number is 60, our proton is 27. So if we collect like terms, our N is equal to 60 minus 27. This will give us 33. That means it is 27, 33, and 27. So our answer is it, you see, is B. As simple as that. Don't forget, proton number is the same thing as atomic number. And it can also be electron number if there is no loss or gain of electron, that means there is no reaction. And you get neutron number by subtracting the proton number from the mass number. As simple as that. Let's go to the next question. Which experiment led to the measurement of the charge on an electron? Scattering alpha particle, discharge tube experiment, oil drop experiment, mass spectrometric experiment. Please take note. The experiment that led to the measurement of charge on an electron is different from the one J.J. Thomson did, where he measured the ratio of the charge to the mass of an electron. So most times they confuse students with this. If they ask you who measured the charge to mass of an electron, that's J.J. Thomson. But what led to the charge on an electron is Millikan's experiment, which we call oil drop experiment. So our answer is what? C. Scattering alpha particles was conducted by Ernest Rutherford with other two scientists, as earlier mentioned. Discharge tube experiment was the second experiment J.J. Thomson did that he discovered proton after he did the cathode ray tube experiment. And mass spectrometric experiment was carried out by Aston in the early 20th century, that's around 1919, where he measured the relative atomic mass of elements. So our answer is what? Oil drop experiment. So let's take the last question. The component of an atom that contributes least to its mass is remember we said this, in the three subatomic particles, proton, electron, and neutron. Electron contributes least to the mass of an atom. We said the proton is about 1,840 times the size of the electron. So the least is what? The electron. The proton and the neutron have the same units. They are over 1,000 times heavier than electrons. So our answer is electron. Future rockstars, did you gain something from this video today? Please help us to share so others also can be equipped with chemistry knowledge. Others can also be ignited with this knowledge. Also do well to hit the subscribe button. Turn on the notification, like it. When you like the video, it helps YouTube to move it so that it can also reach out to more viewers. In the next class, we will be advancing to the second part of our atomic structure series, where we will be talking about isotopes, relative atomic mass, and relative molecular mass. You can't afford to miss that class. So I remain your host, Josh White, leaving to catch you another day. Shalom.